A midpoint divides a line segment into equal halves, making those equal halves congruent to each other. So for this proof, we have this line segment, BARF. If A is a midpoint of BR, that would stand the reason that it would cut this in half, right? So that means BA is equal to AR. If R is a midpoint of AF, then again, we would know that AR is equal to RF. It cuts it into equal parts. We are done with this problem when we prove that BR equals AF. So let's start with this. If A is a midpoint of BR, then what do we know? What can we say? Well, by definition of the midpoint, we can say that if A is a midpoint of BR, then this length is half of the entire length. We can also say that about AR. So make sure you understand what we just wrote. A lot of you just write but don't think. Think about what we're saying here. What does it mean? What are the implications? Because I want you to do the same thing about the other given statement. I want you to do the same thing about R being the midpoint of AF. So in other words, if R is the midpoint of AF, then what do we know? Right? Fill that in. So you should have been able to come up with a statement like this. Now it's important that we look at both of these, because we need to see the following. We notice that this is AR, and we notice that this is AR. So that's our next step in the progression. So we know that AR is 1/2 BR, but AR is also 1/2 AF. So AR is one thing, but AR is also another thing. Because AR can be one of these two things, we could set them equal to each other. So if we use the substitution property, we can set them equal to each other. And we get this equation. Now, if we were to multiply both sides by 2, right? So that's the multiplication property. These 2's cancel out, and these 2's cancel out, and we get BR is equal to AF. And we are done, because our job was to prove that BR is equal to AF. I would strongly suggest pausing, thinking, writing down some words, summarizing, maybe even trying this problem again on your own. Let's work on some of those algebra skills. Here's another midpoint problem. So we were told that M is a midpoint of this entire thing. Get into the habit of making these if-then statements. We call if-then statements conditional statements. So something will happen if a condition is met. Okay. So if M is a midpoint of VW, we could say, like we did before, right, that 1/2 of VW is VM, but that's not what's going to help us here. What's going to help us here is knowing that if something is a midpoint, it cuts it in half. If it cuts it in half, they're equal halves. So if M is a midpoint of VW, we can say that VM is equal to MW. And that allows us to do some algebra, because VM is 4x minus 1. And MW is 3x plus 3. We can add 1 to both sides. We can then subtract 3x from both sides. And we get that x equals 4. But we need to find the length of VM. So how do we get that? We found a value for x, but we actually want the full length of VM. Recall from the diagram that VM is 4x minus 1. If we plug in or substitute back that 4, we get 16 minus 1 is 15. So the length of VM is 15. We take a moment here to note that if VM is 15, then MW would also have to equal to 15 because they're both equal parts. Now you can always check this for yourself, right? If you plug in a 4 in for the 3, that's 3 times 4 is 12 plus 3 is 15. Okay, but from a conceptual point of view, you would just note that you don't have to do that math because they both have to be equal to each other. So we introduce another fancy word, and that's to bisect. So something is we say something is called a bisector if it's a geometric shape that cuts things in half. The midpoint is one special case of a bisector because it's a point. But bisectors could also be lines. They could also be other geometric shapes. So for problem 3, let's go ahead and draw a line segment MH. And we'll draw the midpoint at A. Right? This cuts it in half. AH, there's a midpoint between that. We'll call that T. So we're spelling the word math, M-A-T-H. We're going to draw a line through point T that is perpendicular to line MH. Now, we haven't talked about perpendicular officially yet, but you are aware that they form a right angle. There's my right angle right there. And we're supposed to label that. That's going to be line K. So don't put any points on this line. Just call it lowercase k. We say that line K bisects line segment AH. You see it forms this congruent piece to this congruent piece. The line cuts it in half. It goes to the midpoint, so we know that it cuts in half because the midpoint divides it in half. The midpoint is one type of a bisector that's represented by a point. The line that we just drew is a line bisector. This line bisector happens to be perpendicular, or forming right angles. Let's draw another line through point T, and I'm going to label this line J. So I'm going to just draw one at a weird angle. It's going to be lowercase j. That's line J. Question to you, is line J a bisector of AH? Recall that in order to be a bisector, you must divide things in half. Does line J divide this into two equal parts? Well, I do have this right here. I have AT. And then I have this right here, AH. And they are equal. So a bisector doesn't have to be perfectly straight perpendicular down the middle. It is going through the middle, but it doesn't have to be at a perfect angle. So if I have a line segment and I just cut it like this, and this side happens to be 2 and this side happens to be 3, that's not a bisector because it cut it into two differently sized parts. If I go ahead and cut it this time in such a way that this happens to be 3, for example, and this happens to be 3, if it cuts it into two equal parts of equal lengths that are congruent, then this line would be a bisector. Even though you might not like the fact that it's not perpendicular, it still is a bisector. Bisectors cut things in half. For your summary, before I do that, so I want to just make it clear. Line J is a bisector of line segment AH. It's just not perpendicular like line K. So line K is a bisector, line J is a bisector. For your summary, is a midpoint a bisector? Explain.